All right, looking at the day 7 homework, I will quickly go through a couple of things. There were some things that don't need as much emphasis as others, such as problem 1, which just wanted the trig ratios, right? I was not trying to find any angles here. If I was, the problem would say right here to find some angles, right? So in this case, I just need to identify sine of y, cosine of y, tangent of y as fractions and then as decimals. Problem 2 is a bit tougher, right? Some of you had questions about this. Determine which of the two acute angles has a cosine of 4 over 5. Well, 4 over 5. In this case, I'm looking at this problem, and I know that 8 over 10 reduces to 4 over 5. So I'm looking for what angle has a cosine of 4 over 5. Well, angle C has an adjacent side of 8 and a hypotenuse of 10, which is the ratio for cosine. So it will be angle C. We do the same thing here with problem 3, but this time we're looking at sine of 5 over 11, right? Sine uses opposite over hypotenuse. Opposite is 5, hypotenuse is 11 for angle A, right? If I was looking at angle C, that wouldn't be the same thing. This one just wants it as a decimal, right? But clearly that's going to include 24 over 25 because it's not going to include 7. Here is where we are starting to find angle measures, right? Sine of angle D is 0.75. Find the measure of angle D. Well, that's inverse sine 0.75. Right, and again, this is just using decimals instead of the ratios that we usually see with right triangles. Solve the right triangle. Here I'm going to talk about how we would solve for the 3 missing pieces, which in this case, angle A, angle C, and side AC. To find side AC, think about what you have. I have AB, I have BC, which means I have 2 out of the 3 sides of a right triangle. I'm going to use the Pythagorean theorem. 10 squared plus 24 squared is equal to AC squared. In that case, AC's got to be 26. To find the measure of angle A, here's where I'm going to have to include some inverse trig. There's angle A. Opposite from angle A is 24. Adjacent to angle A is 10. Now, since I found 26 to start, can you use 26 as your hypotenuse? Sure, but you don't need to use it, right? What if you didn't start with AC, right? So you can still solve it without knowing AC. Opposite and adjacent, I know that this is going to be tangent. Since we're finding the measure of an angle, it's inverse tangent of our ratio opposite, 24, over adjacent, 10, and that will get us the measure of angle A. To find the measure of angle C, you have 2 options. Can I use inverse trig? Sure, I would say inverse tangent, 10 over 24, but I could also just find what the measure of angle A is using this, which in this case you get 67.4, and then just do 180 minus 90 minus 67.4. Sure, but maybe you started with angle C, and that's fine. You would use inverse tangent, again, because adjacent, opposite, well, actually those split. Whoops. Angle C now has 10 as its opposite side, and 24 is its adjacent side. See what happens when you work too fast? To find the measure of angle C, we would do opposite over adjacent, inverse tangent, 10 over 24, which would get you measure of angle C, 22.6. Missing 2 angles, you're going to have to use inverse trig somewhere. Okay, again, we're missing 2 angles, so we know we're going to have to use inverse trig. To find DE, that's going to be the Pythagorean theorem. 8 squared plus 14 squared is going to have to get me ED squared. If you put your answer in as a reduced radical, right, I would also accept that answer. I'm not exactly sure what that would be for 16.1. But I'm okay with you putting it as a decimal, and the problem says to round your answer to the nearest tenth. To find the measure of angle E, 14 is your opposite side, 8 is your adjacent side. So I know I'm going to have to use inverse tangent. Tangent uses opposite over adjacent, and that would get me the measure of angle E. Maybe, though, you wanted to start with angle D, so maybe we're over here. So now your opposite side is 8 and your adjacent side is 14, because now we're looking at angle D. To find angle D, I'm still using inverse tangent, but now opposite is 8, adjacent is 14. Either or would be okay there. But again, once you find one angle, you may not need to use inverse trig again, because you could just subtract from 180. Okay. Let's see. Different type of problem here, where yes, we're still solving the right triangle, but we now have two of the angles, and we're missing two sides. This is when we're going to need to rely on basic trig over inverse trig. Let's look at KL first. To find the length of KL, KL is my opposite side, and I know the length of my hypotenuse. The only trig function that uses opposite and hypotenuse is going to be sine. We would say sine of 40 is equal to KL over 8. And again, we put sine of 40 over 1 to set up our cross multiplication. 8 times sine of 40, that's how I'm going to get 5.1. To find ML, ML is down here. I know that that's my adjacent side. And that 8 is still the hypotenuse. Even though I'm looking at a different angle, my hypotenuse is the same. That's where we would use cosine, because cosine is the only one that uses adjacent and hypotenuse. Cross multiply, 8 times cosine of 40 is how we're going to get 6.1. And then for angle K, yes, you can use inverse trig with either 5.1 or 6.1, right? That was 6.1, that was 5.1. You could use those, but can you just subtract them from 180? Yes. Right, I know that these three angles have to add up to 180. That angle's got to be 50. And then I will just show you the work for 10, because 10 works out to be pretty similar. Again, you have two angles, and you are missing two sides and an angle. RS is my adjacent side. 15 is my opposite side. That's tangent. However, RS, I just left it as RS. If you want to call it X and Y, go for it. Adjacent side is the one that we're looking for, and we have the opposite side. When we use trig here, what we are solving for ends up in the denominator. It's okay to have that, but you need to recognize that the thing that you're solving for doesn't always go on top. So now I have RS times tangent of 57 is equal to 1 times 15. Here's where I'm going to need to divide both sides by tangent of 57 in order to get RS by itself. That gets you 9.7. RT ends up working out to be about the same thing, right? Because again, maybe we can call it Y. Again, I just called it RT. But 15 is the opposite still. RT is now the hypotenuse, and what you're solving for ends up going in the denominator. I know I have to use sine because sine is the only one that uses opposite over hypotenuse. RT times sine of 57 is equal to 15. Divide both sides by sine of 57, and you should get 17.9. Same thing for the last angle, right? All of these have to add up to 180. That means that that last angle has to be 33. Now again, I know this wasn't going over every single problem, right? But hopefully there were some that if you had questions on that answer your questions. Right now I would like you to move into the warm-up, and I want you to try that before watching the video.